Alright, this is a very short one. I'm just going to introduce DeMoivre's theorem, okay? So another French mathematician, okay, DeMoivre, and he came up with this really handy theorem. It really follows on from what I've just been talking about, okay, in terms of multiplying, moduli and adding arguments. So if you've got z is equal to r cos theta plus I sin theta, then z to the power of n is equal to r to the power of n cos n theta plus I sin n theta. Just think about that for a moment. Pause the video maybe. Yeah, as an example, say you've got z is equal to, let's just choose 2 because it's a simple number, and let's just choose an argument of pi over 4 because it's a simple angle, okay? So if z is equal to that, okay, well what is z squared going to be? Well, 2 squared is 4, and then you're going to have cos pi over 2, aren't you? Plus I sin pi over 2, because what you're doing is just multiplying the moduli, 2 times 2, add the arguments, pi over 4 times pi over 4. Remember, z squared is z times by itself. And then z cubed, what you're going to do? Well, z cubed is the same as z squared times z. So that times that. So that's 4 times 2, which is 8. But what I'm going to do now instead is I'm going to write it as powers of 2. Okay, so instead of 4, could have written 2 squared. That's going to be 2 cubed, isn't it? Okay, and then add that to that. You're going to have cos 3 pi over 4 plus I sin 3 pi over 4. Not that you need it, but I'll do another one. Okay, z to the power of 4. That's equal to 2 to the power of 4, because you can have z cubed times z, so that times that. Okay, and is equal to cos pi, because you're going to have that argument plus I sin pi, and so on. So if I do z to the power of 5, what I'm going to do is I'm just going to keep on multiplying the modulus by 2, and I'm going to keep on adding pi over 4 to the argument. Okay. Hence this result here. When you've got z to the power of n, you're just going to be multiplying r by itself n times, so r to the power of n. You'll be adding the argument, okay, n times, so n times theta. Okay, so it's a really nice, handy little result, okay. And in terms of how you write it in polar form, that's pretty easy as well. Okay, let me just show you that. So in polar form, if you've got z is equal to r e to the I theta, and then you've got z to the n is equal to r to the n. I'm hoping this one's a little bit more obvious, really, because you know that if you've got e to the I theta, all to the power of n, just use the rules of indices there. You just do n multiplied by all of that, okay? So that's written as I n theta, okay? So that's kind of nice. Yeah. Anyway, that's DeMoivre's theorem. Told you it'd be a quick video.